Sergio Salcido, and this is my function calls project. Associated with this project, what we're going to be doing is we're going to be using integers and mathematical equations to utilize the calling conventions of fastcall, cdcl, and std call. Now, this is my main source file of assembly code, and I'll scroll through here so you can see what's going on, and then we're going to walk through it together. Now, things first, of course, I made sure that everything was set up and linked correctly so there was no syntax errors, and we can walk through this together. And something you'll notice here is I have a file for each one of the calling conventions. And we'll go walk through that and show you what's going on. Alrighty, so start the debugging. First things first, we have the registers loaded with integers of EAX is 8, BX is 5, ECX is 3, and EDX is 2. And we are in that fast call file. And what we're going to be doing here, going to be the first step here is adding EAX and EBX, which is 8 and 5, and we get that total of 13, which 000D hexadecimal for 13. And then next here we have ECX and EDX being added, which is our 3 and 2, which gives a total of 5, which we see in ECX. And then subtracting the 2, we're going to get the total of 8. And so that mathematical equation was EAX plus EBX in parentheses, subtract ECX plus EDX within parentheses. And then from there, we'll return back to our main page. And then what we're doing here is we're moving that results that we just got into EAX. And then from there, we're going to go ahead and go into our second test or second line of integers, which that plus 4 is going ahead and using that second line of integers, which is 7, 4, 2, and 1. And so these moves are just loading those into our registers, which we see up top. Now they are loaded in, and then we're going to go into that fast call file. We're going to add EAX and EBX, so 7 plus 4, and we're going to get the total of 11, which is 000B in hexadecimal. And then we're going to add 2 and 1, and we get 3. It's C in ECX. And then we're going to subtract the 2 to get a total of 8 once more. And then we're going to return back to our program and move that result into EAX. And then the next section here is the cdcl. And what we have here at first is pushing the integers into the call stack. So the first one is 3, the next one is 2, then 3, then 5, and then 7. So now they're all in the call stack, and we go to the file for the cdcl. And so the first thing we have here is push EBP and then the move EBP to ESP. So what that's doing is it's using the addressing to be able to achieve those or get to those variables or integers that we just loaded in the call stack. And then the first one here is loading A, which is 7. And then we're going to go ahead and add it to B, which is 5. And so from there we get the total of 12, which is 00C in hexadecimal. And then here we're going to be loading C, which is 3, and then we're going to be adding it to D, which is 2. So we're going to get the total of 5 as seen in EDX. And then we're going to go ahead and subtract the 2 from each other. So that's 12 subtract 5 gives us a total of 7. And then we're going to multiply it by E, which is 3, and that'll give us a total of 21, which is 00015 in hexadecimal. And so the mathematical equation here was A plus B in parentheses, subtract C plus D in parentheses times E. And then the pop EBP is popping the addresses, popping us out of the addresses of the call stack, and then the returner is returning us to our source page. And then we have this add ESP20. So what that's doing is it's the caller freeing up the space within the call stack. So what that's doing is it's adding 20 bits of space, which was the same amount of bits that we used for all of our integers within that process. And then we're moving that answer to EAX. And then here we have the pushes for the second set of integers. And we're just going in and pushing those into the call stack, just as the same as the last one. And then we go to that file once more, getting into the addressing of that call stack. And then here with the integers in the call stack, we are loading 6, which is A. And then we're going to go ahead and add that to B, which is 4, and we get the total of 10, which is the hexadecimal of 000A. And then next we're loading C, which is 2, and then adding it to D, which is 1, so we get the total of 3. And then we're going to go and subtract the 2. 10 subtract 3 gives a total of 7. and then we're multiplying by e, which in this case is 2. And then so we get the total of 14, which is 0, 0, 0, 0, e. And then we're going to go ahead and pop out of the addressing and then return back to our main page. And then we're going to add the bits to free up call stack. And then moving our answer to EAX. And then once more, we're going to be doing the same mathematical equation and using the same integers for std call. And so we see here us loading it into the call stack, 3, 2, 3, 5, and 7. And then going into the file for that call. And we pop into the addressing because now they're currently in the call stack. And here we're loading A, which is 7. And then go ahead and add it to B, which is 5. And we're getting it that total of 12. And then here we're loading C, which is 3. And then we're going to add it to D, which is 2, and we get that total of 5. And then we're going to go and subtract the 2 to get 7. And then times E, which is 3. And that'll give us that total of 21. Once more. And then here, we're going to pop out of the addressing. And then we have the call E clearing the call stack here, which is that return 20, which is freeing up that 20 bits within the call stack that we just used for all those integers. And we pop back into our main source, and then we move that answer to EX once more. And then the same thing here for the second set of integers, and that's what that +4 is. It's just moving from the first set of integers over to the second set of integers, which is 1 byte. And then so once more, we're pushing it into the call stack, which is 2, 1, 2, 4, and 6. And then we hop into our file to go ahead and hop into the addressing or the call stack where those are at. And then we're loading A, which is 6, adding it to B, which is 4 to get 10. And then loading C, which is 2, adding it to D, which is 1 to get the total of 3, subtracting the 2 to get 7, and then multiplying it by 2 or E to get that total of 14. And then from there, we out of the addressing, and then we free up that call stack with the return 20, which is the call E clearing the call stack. And then from there, that is everything associated with call, CDCL, and std call. And that is the end of the project. Thank you so much for your time.